All right, 1.7 inequalities. So to start with, we are going to solve each inequality, give the solution set in interval notation. So number 14, got negative 3x minus 8 is less than or equal to 7. So just like if this was an equality, I go about solving it the same way. The only difference is if I multiply or divide by negative. So I add 8 first, so I get negative 3x is less than or equal to 15. Then when I divide by that negative 3 on both sides, the inequality has to flip direction. So x is greater than or equal to negative 5. Now they want our answer in interval notation, so if it's a greater than or equal to or a less than or equal to, we use brackets. If it's just less than or just greater than, we use parentheses. So our answer for this, if x is greater than or equal to negative 5, that means that we would have a bracket on negative 5, and x is greater than, so it's going anywhere out to infinity. On infinity, we always have a parentheses. Infinity can never have a bracket because it's not like a known like set number or anything. (20) 2 minus 4x plus 5 times x minus 1 is less than negative 6 times x minus 2. So I'm going to distribute and then combine like terms wherever I can, and then I'll start moving stuff around. So on this side, 2 minus 4x, distribute plus 5x minus 5 is less than negative 6x plus 12. I'm going to combine like terms on the left, so that's going to give me x minus 3 is less than negative 6x plus 12. I'm going to move variables to the left, numbers to the right. So 7x is less than 15. So then x is less than 15 over 7. So when I write my answer in interval notation, this is just less than. So I'm using parentheses. If x is less than that, then that means anywhere from negative infinity up to 15 over 7, but we're not including it because it's not or equal to, so it's a parentheses on both ends this time. Any questions on those so far? All right, we're going to jump a little bit. So these ones have all just had one inequality symbol in them, but we're going to jump down to some that are compound inequalities. So 32, I've got negative 6 is less than or equal to 6x plus 3, less than or equal to 21. So when I have one like this, anything that I do, like normally if I like subtract 3, I'm subtracting it from both sides. So with this one, I technically have 3 sections. So if I am going to subtract 3, I have to do it from all three pieces. So I'll be subtracting 3 from over here, technically subtracting 3 from the middle, which is what makes it go away, and then I'll also be subtracting 3 over here. And same thing if we're multiplying, dividing, whatever. So when I subtract 3, I get negative 9 less than or equal to 6x less than or equal to 18. Then divide by 6 all the way across. So this would be negative 9 over 6, which I will reduce, is less than or equal to x less than or equal to 18 over 6. And just like for the sake of just making sure that we understand, if that 6 was negative, both inequalities would flip just like they did up here in this one when we divided by negative. So this will reduce to negative 3 over 2 is less than or equal to x less than or equal to 3. So then I'm going to bracket off negative 3 halves to 3, because both things are or equal to, and x is between those numbers, so the interval is anywhere including those and anything in between. Let's see, 36. Negative 5 is less than or equal to x minus 3 over 3 less than or equal to 1. So with one like this, I have to start out by multiplying 3 by everything. So I'm going to have 3 times negative 5, negative 15, less than or equal to x minus 3, less than or equal to 3 times 1 is 3. Then in the middle, I still have a minus 3, so I need to add 3 everywhere. So when I add 3, I will have negative 12, less than or equal to x, less than or equal to 6. So now x is anywhere in between negative 12 and 6, including negative 12 and 6. So my interval will be from negative 12 to 6 with brackets. And the other thing is you could potentially have one where like one of them is like an or equal to and the other one is not. So just make sure you pay attention to the inequalities to know if it's going to be like a bracket or a parentheses, if it's just less than, just greater than, or if it's an or equal to one. So those are like relatively basic inequalities. We can also have quadratic inequalities, which will kind of solve the same way as we did just an equality. In the last chapter, I was going to say last chapter, it's still the same chapter, but in one of the last sections, so number 40, x squared minus 7x plus 10 is greater than 0. So what I do is I am going to factor if possible, and if not, I have to go to another method, but fortunately most of these should factor. The other thing is we also have to check for extraneous solutions at the end to make sure everything works and that there's no like false information. So ignore the greater than 0 part right now. If I just wanted you to factor that, what would that factor into? Or what would my factors of 10 that add up to negative 7 be? Negative 5, negative 2. So that'll be x minus 5 and x minus 2 greater than 0. And then now, just like we had the 0 factor property for equalities, the same thing like works for inequalities. We'll set each piece, but instead of it being equal to 0, it's going to be greater than 0, and then we'll solve, and then we'll just have to plug numbers in and make sure that they actually work. So x minus 5 greater than 0, x minus 2 is greater than 0, so x is greater than 5, or over here x is greater than 2. So essentially, I just need to pick a number and make sure that, like, both of them work. So it's got to be greater than 2, so I'm going to say 3. So if I plug in 3, I would have 3 squared minus 7 times 3 plus 10 greater than 0. So 9 minus 21 plus 10. So that would be 19 minus 21, which would be negative 2, which is not greater than 0. So that one isn't going to work. I would check like 6 for this one because that's obviously just a little bit greater than 5. So 6 squared minus 7 times 6 plus 10. 36 plus 10 is 46 minus 7 times 6 is 42. 4 is greater than 0, so this would be my answer here. Oh, and they do want these in interval notation, so this would be x is greater than 5, so in parentheses 5 to infinity, and that would be my answer right there. Let's see. Let's go 44. Negative x squared minus 6x minus 16 is greater than negative 8. What do you notice about this problem? They're all negative. What else?
You can factor it.
Maybe. What's different about this problem compared to the last one? Besides the fact that all the numbers are negative.
It's not equal to 0.
It's not equal to 0. So I need to first and foremost move that negative 8 over. So that's going to be negative x squared minus 6x minus 8 is greater than 0. Now, I don't know about you, but I prefer to deal with positive numbers. I just think, it's easier. So I can factor out a negative from this whole thing and make them all positive. So essentially this would become negative times all of these things being positive. Well, I could divide then by negative 1. 0 divided by negative 1 is just 0. So I would be left with x squared plus 6x plus 8 is greater than 0. And then now, try to factor. What would this factor into?
X plus 4.
Yep, x plus 4 and x plus 2. Does anybody catch a mistake? Yep, I should have flipped the sign here when we divided by negative. I'm going to give y'all a cookie point. Have I explained cookie points to y'all before? So if you earn 10 cookie points, meaning you find 10 mistakes in my math, then you get a pack of cookies as a class to split. And I let y'all just pick the type of cookie. No, not crumble cookies, because I've had people ask that before. Not going crazy, but I have had a class ask for Chick-fil-A cookies before. So, anyways, whatever you need for motivation, find my mistakes. All right, so now I have flipped the inequality. So, x plus 4 is less than 0. X plus 2 is less than 0. So, x is less than negative 4, or x is less than negative 2. Now I want to check a number in there and see what happens to verify that these do or don't work. So I'm going to use the original when I do this. You don't necessarily have to if you're confident that whatever you did here is right, but I usually stick to the original so I can verify that everything's good. So I'm going to use negative 5 down here. So negative times negative 5 squared minus 6 times negative 5 minus 16 is greater than negative 8. So this negative 5 squared is going to be a positive 25 times a negative, because notice this negative out here is in front of the x. It's not being squared also. So this is going to be negative 25. I said I'm picking negative 5 because it's a number less than negative 4. Plus 30 minus 16 is greater than negative 8. So what do we got? 5 minus 16 is greater than negative 8. Well, that's going to be negative 11 greater than negative 8. That's not true. So slash through that one. Then we know that negative 4, like, we can't use that. And we know that we can't use negative 2. So really my only option in here is to test negative 3. So negative times negative 3 squared minus 6 times negative 3 minus 16 is greater than negative 8. So this is going to be negative 9 plus 18 minus 16 is greater than negative 8. So that's 9 minus 16, which is going to be negative 7, which is greater than negative 8. So this is going to be the only one that works. Interval notation, what would my answer be?
Parenthesis negative infinity negative 2 bracket.
So I said that anything less than negative 4 didn't actually work, right? This one's a little bit of a trick question. So what does that mean that my value has to be between?
Negative 4 and negative 2.
Yep, and it's going to be open on both ends. So because I know that nothing actually less than negative 4 works, and negative 4 causes this to be 0, then I've got to go in between that. So pretty much the only whole number that's going to work, well, it's not even a whole number. The only integer that's going to work is negative 3, but obviously like negative 3.5, negative 3.6712, you know, whatever, like that is going to work too. So let's see what else we have. Solve rational inequalities, give the solution set in interval notation. So these ones start us out with a rational where it looks like this. 6 minus x over x plus 2 is greater than 1. So when I have this, I want to get rid of that fraction. So I'm going to multiply both sides by x plus 2. So it gets rid of it over here. So I end up being left with 6 minus x is greater than x plus 2. And as soon as I do that, I'm back to the stuff that looks like what I initially started the section out with. And so I'm going to move this x over, move this 6 over here. So I'm going to have negative 2x is greater than negative 4. Divide by the negative 2, so I have x is less than 2, so I had to flip the inequality. So x is less than 2, so my answer is negative infinity to 2. Now, the other thing that we're going to potentially have a problem with, though, what can I not have in the denominator of a fraction?
Fraction.
A 0. Is there anything that's going to cause a problem in this then? What would make this 0?
Negative 2.
-2. Is that in this interval?
Yes.
Yeah, so x plus 2 equal to 0, so x equals -2. So I need to go remove that from this interval. So all I'm going to do is I'm going to put a parentheses at -2 and basically say it can be anything but -2 in this interval. So it'll be from -infinity to -2 with a parentheses union -2 to 2. So it says on this interval I can have anything except for -2, but it keeps it within this range here. Now, if you didn't recognize that, I'm probably not super inclined to take off points, but that is technically the right answer. Because a lot of people don't pay attention to that part. All right, last one. It'll be kind of like this, but we're going to have a rational equation on both sides, or a rational function on both sides. So number 70, 4 over x plus 1 is less than 2 over x plus 3. So if this was an equality, I would do something called cross multiplying. It's an inequality. I'm going to do the same thing. So my teacher used to call it be the pretzel. Essentially, I multiply this side over here by x plus 3. I'm going to multiply this side over here by x plus 1. And it gets rid of the fractions. So on this side, I'm going to have 4 times x plus 3 less than, over here, 2 times x plus 1. So 4x plus 12 is less than 2x plus 2. Subtract 2x and subtract 12, so I'm going to get 2x is less than -10. So x is less than -5. So then my interval is -infinity to -5 with parentheses. Now, what numbers would cause a problem here?
-1 and -3.
-1 and -3, are those numbers in my interval? No, so I don't have to worry about them. If they were, I would do the same thing like I did up here and break it up. But those aren't in the interval that I have, so that's why I don't have to deal with them this time. All right, any questions about any of that? All right, then your problems are 13, 19, 31, 37, 43, 59, and 69.